whenever there is a change in the velocity of a body, an acceleration is always produced. So acceleration is equal to the change in velocity divided by time, or the rate of change of velocity. It is change in velocity divided by time taken. Now let us consider a motion of a scooty. It starts from rest. When it is at rest, the velocity of the scooty will be 0. It starts running, and after 5 seconds, let the speed or let the velocity at 5 seconds be 20 meters per second. Here there is a change in the velocity of a scooty. We can say the acceleration of the scooty is change in velocity by time taken. Change in velocity is 20 minus 0. 20 minus 0 divided by time is 5. It is 20 by 5. So the acceleration is 4. Only 4. It will have unit. The unit of acceleration will be velocity by time. The unit of velocity is meter per second, and the unit of time is second. Meter per second divided by second. What is it? Meter per second divided by second. It is meter per second into 1 by second. We get meter per second square. So the SI unit of acceleration is meter per second square. It is a vector quantity. If it is a vector quantity, it has magnitude as well as direction. We can also say that acceleration is equal to the final velocity minus initial velocity divided by time, where v is the final velocity of the body, u is the initial velocity of the body, and t is the time taken. Acceleration is not only an increase in velocity but also decrease in velocity. Such an acceleration in decrease in velocity is called negative acceleration or retardation. It is also called deceleration. So these three names are same. Let us consider an example. Again, the scooty. Initially, the speed is the velocity of the scooty is 20 meters per second. When brakes are applied, it finally stops. When it stops, the velocity becomes 0. Let it be the time taken from 20 meters per second to 0 is 5 seconds. What will be the acceleration? Final velocity minus initial velocity. 0 minus 20 by 5 seconds. 20 minus 20 by 5. It is minus 4 meters per second square. Here we have a negative acceleration. Acceleration can either be uniform or non-uniform. Let's consider the motions of two bodies. For the first case, initially it starts with rest. It starts at rest, and at the first second let it be 2 meters per second. At the second let it be 4 meters per second. At the third second let it be 6 meters per second. Fourth second 8 meters per second. Here it starts from rest. At the first second let it be 2. In 2 seconds, the velocity becomes 5 meter per second. At 3 seconds, again 5 meter per second. At 4 seconds, let it be 10 meter per second. Let us calculate the change in each interval. Change in velocity is true minus 0 is true. 4 minus true, true. 6 minus 4, true. 8 minus 6, true. Here 2 minus 0, true. It is 3. 5 minus 2 is 3. 5 minus 5 is 0. 10 minus 5, 5. Here we see that equal change in velocities in equal intervals of time. Here, non-equal change in velocities in equal intervals of time. So, uniform acceleration is the acceleration of a body when there is equal change in velocities in equal intervals of time. Here, non-equal changes in velocities in equal intervals of time. Now let me give you one example each for uniform acceleration and non-uniform acceleration. For uniform acceleration, let us consider a free-falling object. When we drop something, when we drop a pen, it starts from rest. The velocity increases on the way down. It hits the ground with maximum speed, maximum velocity. So the acceleration produced in such a motion is uniform. So we can write acceleration produced in a freely falling object. Do not write a freely falling object. The object is not acceleration. The acceleration produced in a freely falling object. Okay, listen carefully. You are going to give an example for uniform acceleration. Write acceleration, not the object. Acceleration produced in a freely falling object. Here, for non-uniform acceleration, let us consider a car in a crowded street. Let us consider a car in a crowded street. The speed cannot be constant, and the change in the velocity will also be non-uniform. So we can write acceleration produced in a car in a crowded street. Now let me explain the numerical examples given on page 13. Example number 1. A car starts from rest and picks up a velocity of 18 meters per second in 20 seconds. Calculate the acceleration of the car. It starts from rest. It means the initial velocity is 0. U is the initial velocity. It starts from rest, 0 velocity. And it attains 18 meters per second in 10 seconds. The acceleration is, to calculate the acceleration, it is v minus u by t. Putting the values, v is 18, u is 0, t is 10. 18 minus 0 is 18 by 10. So it is 1.8 meter per second square. Now let's go to question number 2. Calculate the initial velocity of a train which is stopped in 50 seconds by applying brakes. The retardation due to brakes is 0.5 meter per second square. Here we are going to calculate the value of u, the initial velocity. Which is stopped means the final velocity is 0. It is stopped. So it is at rest finally. And the time taken is 50 seconds. Retardation is given, so the acceleration will be taken minus. It will be negative if it is retardation 0.5 meter per second square. Here we are going to find u. The formula is A equals to V minus u by T. Let us put all the values. A is minus 0.5. V minus u, V is 0, u is u. T is 50 seconds. What do you get? Minus 0.5, it is minus 5 by 10. Then 0 minus u is minus u by 50. Let us cancel negative. Cross multiplying, we get u equals to 5 by 10 into 50. 5 by 10 into 50. We have 25 meter per second. Initial velocity of the train is 25 meter per second. Question number 3 is, a train is moving with an initial velocity of 30 meter per second. The brakes are applied so as to produce a uniform acceleration of minus 1.5 meter per second square. Calculate the time in which it will come to rest. The initial velocity is given here, 30 meter per second. What else? The brakes are applied so as to produce the acceleration of minus 1.5 meter per second square. To calculate the time when it comes to rest. If it comes to rest, the final velocity v is 0. The formula is A equals to v minus u by t. Here we are going to calculate t. So let us interchange the positions of A and t. It is cross multiplication. T equals to v minus u by A. V is 0, u is 30, A is minus 1.5. Minus 30 by minus 1.5. 30 by 15. We can write 0. 15 twos are 0, so then the time is 20 seconds.